Hey everyone, in today's digital world, apps are getting seriously complex. We're talking tons of features, constant updates, it's a lot to handle. And for developers, one of the biggest headaches is compatibility. Will that code that runs perfectly on your Windows machine work the same on a Linux server? That it works on my machine problem can be a nightmare. But don't worry, there's a hero in this story and its name is Docker. Docker is a powerful tool that's here to save the day. In simple terms, it packages your application and everything it needs to run smoothly, like a neat little self-contained box. Imagine a shipping container that carries goods across the world. Docker is similar. It creates a consistent environment for your app so it runs the same way everywhere, from your laptop to the cloud. In this video, we're diving deep into the world of Docker. We'll learn what it is, how it works, and most importantly, how to use it to containerize your Node.js applications. So buckle up and let's get started. Okay, let's break down what Docker actually is. Imagine you're baking a cake. You need all the ingredients measured out and ready to go, right? Docker does something similar for your software. It bundles your application code, libraries, dependencies, and even the operating system, everything it needs to run, into a neat package called a container. This container acts like a mini computer, completely isolated from your main system. This means your app runs consistently, no matter where that container is placed, your laptop, a server, or the cloud. It's like magic, but it's really just clever engineering. Now let's dive into the fundamental building blocks of Docker, which are essential for understanding how this powerful tool works. First up, we have the Docker engine. This is the core component that makes everything else possible. Think of the Docker engine as the heart of the operation, pumping life into your applications. The Docker engine has two main parts: the client, which is what you interact with, like the Docker command line interface, and the server, or daemon, which does the heavy lifting of building and running your containers. The client sends commands to the daemon, which then executes them. Next, we have Docker images. These are crucial for creating containers. Think of Docker images as blueprints for your containers. They provide the detailed plans needed to build your application environment. An image contains everything needed to create a container, including the operating system, libraries, and your application code. This ensures consistency across different environments. You can either use pre-built images from Docker Hub, think of it as an app store for Docker images, or create your own custom images tailored to your specific needs. Finally, we have Docker containers. These are the actual running instances of your images, bringing your applications to life. When you run a Docker image, you create a container. This container is an isolated environment where your application runs. Running a Docker image to create a container is like taking that cake recipe, the image, and baking a real cake, the container, that you can then share and enjoy. Each container is a separate instance, allowing you to run multiple containers simultaneously without conflicts. This analogy helps illustrate how Docker images and containers work together to make application deployment and management more efficient and reliable. With Docker, you can ensure that your applications run smoothly in any environment. Before we move on, let's quickly define a few key Docker terms you'll come across. Docker engine, the core of Docker, responsible for building and running containers. It acts as the intermediary between your commands and the Docker daemon. Docker image, a read-only template containing the application code, libraries, and dependencies needed to create a Docker container. Docker container, a running instance of a Docker image. It's a lightweight and portable execution environment where your application runs in isolation. Think of it as a self-contained mini computer. Now, if you're a back-end developer, you might be thinking, okay, this Docker thing sounds cool, but how does it actually benefit me? Well, get ready to be amazed. First off, Docker is like a dream come true for DevOps, that magical blend of development and operations. It streamlines the entire process of building, shipping, and running your applications, making collaboration between teams smoother than ever. Docker is also incredibly flexible. Whether you're building microservices, those small independent units of code, or working with more traditional monolithic applications, Docker can handle it all with grace and ease. Remember that dreaded dependency hell we talked about earlier? You know, when your app breaks because of conflicting libraries or missing components? Well, Docker says sayonara to all that. Since a Docker container bundles everything your app needs, you can kiss those compatibility issues goodbye. No more spending hours troubleshooting why something works on one machine but not another. And let's not forget about scalability. Docker makes it super easy to scale your applications up or down based on demand. Need more power? Just spin up more containers. It's like having an army of mini servers at your fingertips. Alright, let's get Docker up and running on your Windows machine. But before we dive into the installation, we need to make sure your system is ready to handle the awesomeness of Docker. First things first, check your Windows version. You'll need Windows 10 Home or later. Older versions unfortunately won't cut it. Next, we need to talk about WSL2. Now, this might sound a bit technical, but don't worry, it's not as scary as it seems. WSL2 stands for Windows Subsystem for Linux 2, and it's basically a way to run a full-fledged Linux environment right inside Windows. It's like having a secret superpower. Now that your system is prepped and ready, let's download Docker Desktop. Head over to the official Docker website using your favorite web browser. You'll find a section dedicated to Docker Desktop downloads. Make sure you select the right version for Windows. Docker is kind enough to detect your operating system automatically, but it's always good to double-check. Once the download is complete, locate the installer file, it usually ends with .x, and double-click it to begin the installation. You'll be greeted with a friendly installation wizard. Just follow the on-screen instructions and you'll be good to go. The installer will take care of everything, from setting up Docker Engine to configuring WSL2 if you don't have it already. Congratulations, you've successfully installed Docker Desktop on your Windows machine. But wait, there's more. Let's make sure everything is working as expected. Open up your command prompt or PowerShell window and type in the following command. Docker version. Hit enter, and you should see the Docker version you just installed. If you see it, you're good to go. Now let's take a peek at Docker Desktop itself. You'll find it in your system tray, usually in the bottom right corner of your screen. Click on the Docker icon, and a handy dashboard will pop up. This dashboard is your control center for all things Docker. You can manage your images, containers, and even connect to Docker Hub right from here. Alright, now that you have Docker up and running, it's time to create the heart of our containerization process, the Dockerfile. Think of a Dockerfile as a recipe, a set of instructions that Docker will follow to build your application's image. It's like a script, but instead of telling a computer what to do, it tells Docker how to assemble all the pieces of your application into a neat, portable package. In this Dockerfile, we'll specify things like the base image to use. Remember, that's the foundation of our container, the working directory for our application code, any dependencies that need to be installed, and finally, the command to start our application when the container is run. Let's get our hands dirty and start creating our Dockerfile. In your project folder, that's where your Node.js application code lives. Create a new file named Dockerfile without any extensions. First things first, we need to tell Docker what base image to use. Since we're building a Node.js application, we'll start with a Node.js image. Add the following line to your Docker file. This line tells Docker to use the official Node.js image, specifically version 18 Alpine. Now you might be wondering, what's with the Alpine? Alpine is a super lightweight Linux distribution that's perfect for Docker images. It helps keep our image size small and improves performance. Now that we have our base image, let's set the working directory inside our container. This is where our application code will live. Add the following line to your Docker file. Next up, let's copy our applications and files into the container. These files contain information about our application's dependencies. Add these lines. Now, it's time to install those dependencies. Add the following line. This line tells Docker to run inside our container, which will install all the necessary packages based on our file. We're almost there. Let's copy the rest of our application code into the container. Add this line. This line copies everything from our current directory on our local machine into the container's working directory, which is. Next, add this line. This line tells Docker to expose port 3000 from our container. This is important because our Node.js application will be listening on this port, and we'll need to access it from our host machine, which is our computer. We've crafted our Dockerfile, our blueprint for containerization. This file contains all the instructions needed to create a Docker image, from the base image to the commands that need to be run. Now, let's fire up Docker and bring our image to life. This is where the magic happens, transforming our code and dependencies into a portable container. Open your trusty terminal or command prompt, navigate to your project folder where your Docker file resides, and type in this command. Let's break this down. The command tells Docker to build an image based on the instructions in our Docker file. The flag lets us tag our image with a name. In this case, the at the end specifies the build context, which is our current directory. This tells Docker to look for the Docker file and any other necessary files in the current folder. Hit enter and watch Docker work its magic. This is where Docker takes over and starts building the image. It will read your Docker file step by step and execute each instruction. This includes setting up the environment, copying files, and running any specified commands. You'll see output in the terminal as Docker downloads the base image, copies files, installs dependencies, and essentially assembles your container image. Each step is logged so you can see exactly what's happening. Once the build is complete, you'll have a Docker image ready to be run as a container. This image is a snapshot of your application, fully configured and ready to go. With our image built, it's time to run it. Type in the command. Here tells Docker to create and start a container from our image. The flag maps port 3000 in our container to port 3000 on our host machine. This way, when we access in our browser, we'll be talking to our Node.js application running inside the container. Hit enter, and Docker will launch your container. You should see your Node.js application spring to life, accessible in your browser. And there you have it. You've successfully containerized your Node.js application using Docker. And there you have it. We've journeyed into the world of Docker, exploring its power, flexibility, and how it can make your life as a developer a whole lot easier. We started with the basics, understanding what Docker is and why it's such a game changer for modern application development. We then rolled up our sleeves and got our hands dirty, installing Docker, writing our very own Docker file, and building a containerized version of our Node.js application. And finally, we witnessed the magic of Docker as we ran our app inside a container, completely isolated and self-contained. So congratulations, you've taken your first steps into the world of containerization, and trust me, this is just the beginning of an exciting journey. But hold on, there's so much more to discover. Docker is not just a tool, it's a gateway to a new world of possibilities. Docker is a vast and powerful tool, and what we've covered today is just the tip of the iceberg. The more you explore, the more you'll realize its potential. As you delve deeper, you'll uncover a treasure trove of features and capabilities that will revolutionize the way you develop, deploy, and manage your applications. From simplifying complex workflows to enhancing collaboration among teams, Docker has it all. Imagine orchestrating entire fleets of containers, scaling your applications effortlessly, and ensuring high availability and reliability. With Docker, you can automate your entire development workflow, from code integration to deployment, making your processes more efficient and error-free. With Docker, these dreams become a reality. The satisfaction of seeing your applications run smoothly and efficiently is unparalleled. Explore the world of Docker Compose, a tool that allows you to define and manage multi-container Docker applications. It simplifies the process of setting up and running complex applications. Dive into Docker Swarm and Kubernetes, powerful orchestration tools that take container management to the next level, enabling you to deploy and scale your applications across clusters of machines. These tools provide robust solutions for managing large-scale applications. With Docker Swarm and Kubernetes, you can achieve seamless scaling, load balancing, and failover, ensuring your applications are always available and performant. Embrace the future of application development with Docker and unlock its full potential. And once you've mastered the art of containerization, why not share your creations with the world? Deploy your containerized applications to the cloud, leveraging the power of platforms like AWS, Google Cloud, and Azure. These cloud providers offer seamless integration with Docker, making it easier than ever to deploy, manage, and scale your applications globally. So go forth, embrace the power of Docker, and unlock a world of possibilities for your applications. And as always, keep exploring, keep learning, and keep pushing the boundaries of what's possible in the ever-evolving world of software development.